start with problem find XOR. So just before we start, I believe we are using the XOR method, so it would be good just to check what it does. So idea is like for XOR, if both zero, we have both zeros or both ones, we get zero. Otherwise, if it's alternative, we just get one. So let's start with the problem. So there is a sequence of n. We have to find the XOR of 1 up till n. Uh, so this seems like an interactive problem. Oh, yeah, this is an interactive problem. What you do is you can ask up to 20 questions, and you can give a k, and what they will do is like they will take XOR of k with each and every single element, and then return the combined sum. Okay, so 22 raised to power 6. What is the value of AI? AI is 10 versus 6. So 2 raised to power 20 is actually greater than 10 raised to power 6. Yeah, just greater than 6. And in fact, it is less than 2 into 10 raised to 6. So I believe like this will be a logarithmic solution wherein like maybe it's kind of like 20 questions which is appropriately fits for each and every bit which we have in a number. So maybe like I will ask keys as like 1, 2, 4, 8, 16 up till 2 raised to power 20. Interaction. So first you have T, then we have N. Uh, okay. Then I have to ask a question directly. I will ask 1 and K, where K is like any number between 1 and 2 raised to us 2 into 10 raised to 6. The answer is either a minus, either the answer like whatever the sum will be, or a minus one if it's an invalid or something. Finally, you print two integers, two space x, where x is what we need to find out. Okay. Okay, then I must read a line containing a single integer. If one, if your answer is correct, or minus one is. If your answer was correct, you should continue solving the remaining test case. And if I receive minus one, I should immediately terminate. Okay. Okay, so I think like one of the major issue which I have had with interactive problems is like making sure that the interaction is fine. So you have to definitely make sure that you do flesh out your output and just wait for that. So let's try implementing it first and then maybe look more into the overall solution later on. So this is nothing but my previous solution, so let me just remove that. Um, yeah, okay, so first of all, let's say we already had T. Uh, then we start with integer n. So let's say int n, then n, then let's say ask question. Let me actually create a method for asking a question and waiting and getting a response. Question. So int A, int B. This can be get response. Let me just make it generic get response so it can be used for like printing one space K or one space the final answer. So cout A, B, cout dot flush, and then int x, cin x, return x if x equal to -1. I simply do a exit. What is exit not supported anymore? Okay, with a condition. So exit one. Mm, okay, this should be good enough for getting the responses and all. So let's focus on the actual solution now. So let me consider like the maximum which I will think like maybe like 2 raised to power 20, which is greater than 10 raised to power 6. If I ask a question for that, what would happen? Then no number will be changed. It will basically be like 2 raised to power 20 plus AI. Like this thing will be 2 raised to power 20 plus AI 2 raised to power 20 plus. So the XOR thing will nothing be but just a sum, and then it will be sum. So ultimately I will get something like n into 2 raised to power 20 plus sum of whole. Would this exceed 20? Okay. Let me just explain in detail. Let me just check this. So the maximum value which I can get if I ask question as 2 raised to power 20 is 2 raised to power 20 into 10 raised to power 3, 2 raised to power 20 into 10 raised to power 3 plus 20 into 10 raised to power 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this is still less than int max. Yes, still less than that. So there won't be an integer overflow. Okay, so and then let me try to reduce the question and maybe take some examples so it becomes easier for us to understand. So let me say that each element is between 1 uh, greater than equal to 1 and less than equal to 10. Also, let us say that I can ask the k, the question which I can ask is double of the max limit, which is 20. K should be strictly less than or equal to 20. Yeah. And the number of questions which I can ask is so like 2 raised to power 4 is 16. So number of questions which I can ask is 4 now. Let us try solving this. So what would actually happen? So let's say if my elements are like 3, 5, 8, let's say 10. Maybe let me write down the binaries of this as well. So this will be 0011, this is 0101, this is 1000, and this is 1010. So first of all, let me ask a question that k equal to 16. So that means I am asking the question first question as 10000, right? 1, 2, 4, 8, 16. Yeah. So when I'm taking an XOR with 16, which is definitely greater than any of these numbers, I know that, and it is like a exact power of 2. I know that this is 1, and all of these will be 0 because these are less than 16. Similarly, all these are 0. That's how I have taken the number, and these will remain as it is. So when I take an XOR, so for this particular binary digit, it will like if I'm taking XOR of 10 with 16 with 10, yeah, this is the initial case. So if I'm taking XOR of 16 with 10, I get 1 over here, and the remaining numbers I will get as it is. So 1 0 1 0. So 1 of 1 and 0's XOR is 1, and so on. So this is actually 26. Similarly for others, this will be extensible, and ultimately I will get like 16 plus 10. Instead of XOR, it becomes kind of like a plus 16 plus 8 dot. So if sum of this entire thing is S, I will get S plus N multiplied by 16, the number which the value K which I chose. So using this, I can actually get the sum of the elements. Okay, now what? I have to find the XOR instead, right? So let's try. So I am able to figure out S with just a single question. Let's try to decrease this. So let me try asking XOR with 8. Okay. So if I take XOR with 8, again, all these things will remain as it is, and all the sums, like this, are nothing like 2 restore 0, 2 restore 1, 2 restore 2, those type of digits, right? And if I take a combination, all the sum, those sum will still be identical to what these binary digits contribute in S, but things will change for these. Okay, so all the ones will become zeros with due to the XOR. Even on the if there are greater number than this, it will remain same, and all the zeros will become one. So let me say that for this particular digit, like where this particular binary digit where we have one, let's say I have x number of ones over here, x ones and y zeros. So due to the swap, it will be like y ones and x zeros. So the increase in sum will be what? Y minus x multiplied by k, right? Because like had it been just one initially, just uh, let's say instead of this like 10, let's say this is 0, which is like 2 over here, then what would happen is if I take an XOR with 8, so 2 becomes 10, that is an increase in 8. 8 becomes 0, that is a decrease in 8 with 8. 5 becomes 13, that is an increase with 8. And 3 becomes 11, that is an increase in 8. So overall, the sum of these will increase by 16. So which will be like y minus x multiplied by k. I can divide by k. So I am able to get y minus x thing. In the final solution, if I need to figure out the XORs of A1, A2, A2, 3, I simply need to figure out whether uh, the number of ones over there is odd or even, something like that. Mhm. So let us consider. So I am able to find the y minus x thing. Let's do this. That y minus x is equal to d and x plus y is n. That's right. Like all the number of elements is just n. So this implies 2y is equal to n plus d and y. So I can basically figure out the y, the number of zeros, and using this I can figure out x, and ultimately I just need the parity of x, whether it was odd or even, and depending on that I can simply, like, if it is odd I will put 1 in the final XOR, and if it was even I will put 0. Okay, so this makes sense. So let me first try to figure out the final sum. So let's say int uh, k is equal to 1 2 raised to power 20, and let me get response int sum is equal to get response. I will first check for 1 comma k, and I will subtract n multiply by k. So this is the final sum which we decided. I can get s using this. Uh, Following that, So k divide equal to k divide equal to 2. So I'm just bitwise shifting. Uh, for k greater than 0, k divide equal to 1. I have to do for each k. What I will do is I will get response first. So what value is this? Like let's call it d. So d will be like whatever response I got divided by k. Divided by k. So this is the d which I got. Uh, so uh, so y will actually be n plus d by 2, and int x is equal to n minus y, and int answer equal to 0 initially. If x is odd, I will say answer plus equal to k, because that's the digit I have to add 1 at. And finally, uh, if get response 2 comma answer equal to -1, I simply exit. Oh wait, I am already doing exit, right? So I do not really need to do something like this. And finally, I just say get response. X and 1. Yep, this seems about right. I think it will be really difficult to set up the entire interaction thing uh, just to try test out this method. So what we can actually do is like maybe try to dry run this instead and see this. This is working out fine. In fact, do I need S then? No, I don't really need S at all. Let me just skip that. So let's verify. So I've got an input n. I went with 2 raised to power 19 thing. I got a response d. So I printed. Okay, I do need s. I do need s. So basically, what is happening is, uh, let me actually bring back this thing. Yeah. And let me just remove this. So what this get response actually returns is this XOR k plus this XOR k plus this XOR k. So regarding these terms are fine, but I have to eliminate this entire thing, right? So basically what I want to do is I like whatever response I got, I will subtract uh, s from that. Wait, if I do subtract s, then what would happen? Hmm. I think my equations will be a little different. Let us still assume that initially I have x number of ones and y number of zeros. Um, and let's say this value, let's say I got v, and my initial sum is s. So v, and let's say this is k for the time being, k equal to 8. So v is equal to s, the initial sum which I had. Let's subtract these number of ones, which is k times x, and then it will add y times of k, right? Yeah. So because like this was the initial sum, because of this particular XOR, my these number of x's like which contributed k multiplied by x sum, this got decreased, and y multiplied by k sum got increased. and this is the final value which I'm obtaining. This implies y minus x, sorry, yeah, y minus x by k is equal to v minus s. This implies y minus x is equal to v minus s by k. So this minus s by k. So that's the diff which I was talking about. So d is actually equal to this, and then obviously x plus y is equal to n. That implies 2y is still n plus d. That means y is n plus d by 2 and x is n minus y, and then just checking for x and y. Yeah, this makes sense now. And k equal to 1. Yeah, this seems all right. Let's try submitting. Submit. Okay. Okay, this is showing as a wrong answer. So I was able to figure out what the issue was and even got an EC on this problem. So for the sake of video, let me just go back to my first solution which I tried out, and like I got a wrong answer, and let's build on that. So one thing just to add, this seems like an issue with the interactive judge, as in I need to print a endline character. If I don't really, it does not recognize my solution. Secondly, what I realized was like I was printing from uh, 2 raised to power 20, so 1 bit was shift 20 up till k greater than 0. That means k will be 1 as well. That means 2 raised to power 0. So these are actually 2 raised to power sorry, these are actually 21 steps. So if I actually change this to 19, this will be like exactly 20 steps, and try submitting. This should give me a solution for like an EC for the smaller subproblem. Reason being, for the smaller subproblem, all the values are less than 100. So this works out perfectly for the smaller subproblem. We can just see. Yeah. So now the question is remaining like how do I find like figure this out in 20 steps instead of 21 steps. So one of the good things which I realized is the value of uh, this particular term, like get response 1 comma k minus s. This is like this will be a multiple of k, right? So let me take a particular case where let's say if k equal to 119, then what would happen is if I take just this particular case, uh, int d will be something like this, uh, and this will be like a multiple of k. So if I say like 2 raised to power 19, that's actually quite a big number. 52448. 5 52428. So this will be a factor, a multiplicative number of like this 52428. Let's call it what? This multiplied by, let's say, q. So this will be something like, say, equal to this. Okay, and like so, just to be precise, if we go like we can do something like this over here as well. This will s minus k into x plus y into k. I'm just like saying that this will be some multiplicative number of this. This q can be positive or it can be negative as well. So for example, it can
this q, it can be like plus n or minus n, whatever, depending on the number of zeros or ones initially. Now, what am thinking of is instead of figuring out just a single bit for each response, I'm trying to club two bits together. So I will just iterate up till k greater than 1, that is k, the minimum value will be 2, and I will take both k and k plus 1 together. So let's call it what? Maybe a different name. Let's call it temp. Now this will be something multiplied by q plus. Now for 1 again there will be some factor like uh, so k plus 1, right? Like this k was 5, 2, 4, 2, 8, 8. This contributed this particular term, and because of 1, if you look closely, it will be like s minus kx plus yk minus x of 0, the 0th bit, plus y of 0th. So I can actually say it like 1 multiplied by maybe a different term, let's say q dash, or maybe let's say r, something like this. Now I know again R will range from either plus n or minus n, because ultimately like that's the only number of the total range for minus x naught plus y naught will be. So just to formalize, this will be equal to s minus k into uh, minus k into x of k. This is like number of ones in the 19th place, 90th bit digit. Uh, Sorry, minus k into x plus number of zeros for the same. Let me denote as at xk by k. Now it will be minus 1 into x of 1 plus 1 into y of 1. So I'm saying that like when I subtract s, so this gets cancelled. This term, like if I take k common, it will be xk yk minus xk, that will be q. Similarly, y1 minus x1, that will be r. Uh, so now what I can do is let's say int temp1 is equal to let's call it r instead. So r will be equal to temp modulo k. Now like what I have to do is I have to make sure that r is in the range of uh, plus n and minus n, because that's what it the number of zeros or number of ones will actually be. Because we are taking modulo, it is possible that this is like something very different, drastically different. So for example, if let's say temp for the total value of this was maybe multiplied by 1, let us say this was this, like r was 0 and value was minus 524 288. I do a modulo of this, a modulo with k, and r comes up. Now r will range from minus k, sorry, uh, plus k till minus k. That's how modulo is implemented in C++. Now what I have to do is I have to shift them in the range n comma minus n. So what I will do is, if r is less than minus n, or if r is less than minus n, then that means it is in the range like minus n up till minus k, and I know for sure I can simply add r plus equal to k, and like I will lie in this range. Similarly, else if r is strictly greater than n, then what I can do is I can simply say r minus equal to k, and that's it. So now I got the R. Similarly, int Q is equal to temp minus R divided by K. And this R and Q are nothing but this D which we had earlier. So maybe let's call it D1 and D1. Okay, maybe just using the variable. So int D1 equal to R, int Dk is equal to Q. Now I can utilize the exact same solution. So this K is K. Now 1, 1. Similarly K, similarly K. Now if x1, I will simply add 1. If xk, I will simply add k. This should be good enough. Let's just try submitting. The reason I know that this can be shifted over here is because of this particular equation, that the temp is actually equal to k multiplied by q plus 1 multiplied by r. It's just that because I'm taking modulo, and if temp is a very negative number, it is possible that I lie in somewhere like which is less than minus n but greater than minus k, and that there will exactly, like for example, if k is this, let us say the value minus 7, this modulo 524888 is actually equal to 1 modulo k. So that's the modular arithmetic, and that's what we are using over here. It seems like a wrong answer. Let's just verify if I did something wrong. So I, like what it is, like I simply did a modulo k. So if r is this is k plus 1, so that's fine. If I need to do a continuous just to make sure that I do not recalculate all this, and this starts from 20, right? Yeah. Seems like it. That's it, and that's an essay. Yeah, that's it for this problem. Thank you.